Kia ora team, and welcome to this video about solutions, solutes and solvents. Today we're going to look at primarily liquids and how dissolving works. So stay tuned and I hope you enjoy. So firstly, what is a solution? Well, a solution is a homogeneous mixture of two or more substances in a single phase. One constituent is usually regarded as a solvent and the others as the solutes. Now there's a lot of big words there, don't panic, I'm going to work through them all soon. So here you can see that we've got two things, constituents. The first being the solvent, usually a liquid, and the second being the solute, a solid. Here you can see when we add some of this into this, we get mixing happening. Now, this will either cause dissolving to occur or not, and that's what we're going to explore today. This is commonly seen in salt and water as a common example used throughout science. So, parts of a solution. Now, what was the solution? I talked about a solute and a solvent. Well, a solution is a solute plus a solvent, and that makes our solution. So here's the example of hot chocolate. So the solute is the part of the solution that is dissolved, usually the lesser amount, so you don't put as much of this in as you have the solvent. The solvent is the part of the solution that dissolves the solute. So the milk here is going to dissolve the hot chocolate, and this is usually the greater amount, and we'll get into why that is in a second. And when you combine the two, you make a solution. So a solute plus a solvent equals a solution. So some other things that you need to know about solutes and solutions. Here's an interesting mix of chemistry ones I've got here. Firstly, they spread evenly throughout the solution. Okay, the solute and solvent. They cannot be separated by filtration. They can be separated by evaporation. So you can't filter them out from each other, but if you evaporate one from the other, that's how you separate them. You usually can't see them, but as the solution appears translucent, so you can see through it, however, it does tend to give it a colour. Okay, so once the solute has dissolved, you can't see it. Okay, if we think back to that powdered example, okay, the powder just makes the water a different colour. So I'm going to throw some more words at you, but they make sense in terms of the words I've already taught you, solute, solvents and solution. So let's have a look at these. Okay, we have soluble. Now soluble is a substance that can be dissolved. Now we know that the solute, that kind of looks like this word, is the thing that is dissolved in a solvent. If you are insoluble, IN in science usually means it can't happen. So being insoluble, you're a substance that cannot be dissolved. Now, there's two other words that are often used to describe being soluble or insoluble, and that is miscible and immiscible. If you're a miscible substance, you are a substance that is soluble in another liquid. That means you can dissolve. If you're immiscible, you're a liquid substance that is insoluble in another liquid. What does that look like? Well, you often see this when you see separation in something. So you can see this line here, and you've got two different liquids. They're not mixing together. So they are immiscible, insoluble. They're not mixing. Whereas this substance over here, we see we've mixed all around, and our two liquids are completely mixed together. Immiscible, miscible. Insoluble, soluble. Hope that makes sense. Let's give you some examples. So, I'm going to sort of pause the video here. I'll get you to pause the video here when I ask you some questions. I really want you to try and answer them yourself. So we're going to look at this example first, salt added to water. The solute in this example is the what? So what do you think is going to dissolve in the water? Right, it's the salt. So the solvent must be the water, correct? This makes what? When you add a solute and a solvent, what were those two things added together called? Right, they make a solution. So which one did I say was the soluble, right, the salt, okay, because it has dissolved. Now, often students get it wrong by saying they've disappeared. That is not correct. It is still there. You just can't see it with your eyes, okay? But it is still there, so we use the word dissolved rather than disappeared. Okay, let's take this example over here. You can clearly see we've got a slightly cloudy mixture. It's not translucent, okay? And after a while, we see that our flour, in this example, sinks to the bottom of the glass. What word would we use to describe the flour? Right, it's insoluble, and that is because it has not dissolved. So hopefully that clears it up with 2 examples for you. All right, so when a solute dissolves, such as the salt in water, where does it go? Does it disappear? And this is just to highlight that often common mistake that we make as students when we're learning this. So here you can see let's call it a crystal of salt, okay, a big chunk of salt. I'm going to put it into water, all right? The solute does not disappear. The salt doesn't disappear. It's still there, but you cannot see it because the particles are now mixed up, or dissolved is the key word you want to use. So look at this particle box here. Can you draw a particle box for a solid which is dissolved? So this into this. Can you do that? Pause the video and have a go. Did you get something like this? The number of salt particles and the number of water particles remains the same. We haven't lost any of the salt particles, and they haven't got any smaller. They're just spread out amongst the water particles. They're mixed together, they're dissolved, which is why we can no longer see them. And that's why often people get it wrong and say it looks like the salt has disappeared. But I bet if you tasted that water, you'd know it's still there. All right, let's try it again. But this time I want you to pause the video and try and draw the flour added to the particle box below, the water. Have a go. All right, did you get something like this? So if we look at the particle box here of the solid, the insoluble solid in the liquid, and we know it doesn't dissolve because it's insoluble, then we should get something that looks like this, remembering that the number of particles and the size should stay the same. But we can see it this time because it hasn't got any smaller, it hasn't been broken up, it hasn't been mixed with our liquid, our solvent, okay, the water. Okay, so here the amount of solute dissolved in a solvent at a given temperature is called the concentration. So how much of the solute, the salt, we are adding to our water is called a concentration. Now, I've got a few examples here. So hot chocolate, the more powdered mix you add, the higher the concentration your chocolate is. A lot of you do this with Raro, the sugary drink that sugary powder you add to your water, which Mr. Lloyd tells you is very bad for you. Okay, and lemonade is the same. The more frozen lemon concentrate you add, the more tart the drink becomes. So when you add your Raro, this is very simple. A low concentration of Raro is maybe half a teaspoon. And you'll all tell me that tastes yuck. Whereas if you put the whole packet in, it's going to be very concentrated. Okay? So that's how you remember concentration. All right? And we can also use some words to describe how concentrated things are. And that is using the words dilute or unsaturated. Now what that means is a solution that has a low concentration of solute. So remember when I was telling you about the Raro, half a teaspoon is going to be quite diluted by the water. So there's going to be more of the water than the Raro. Okay, so that's a good example to use there. And we call that unsaturated. So there's not much of the solute in that solution. Now when we saturate something, if you think about some people use when they get really wet in a rainstorm, being completely saturated. So their clothes have absorbed all the water from the rain and they're completely soaked. All right? It's similar here, except you've got to think about it in terms of the Raro. You know when you add so much Raro to your water that it doesn't dissolve, you get that little bit of sugar at the bottom. That's when a solution is saturated. Okay? There's no more room to fit the solute, the Raro, into the water, the solvent. Okay, so the solution, them together, is so saturated, all right, it contains the maximum amount of solute that can be dissolved at a given temperature. Now, if you use temperature here, okay, you'll often find when you heat something up, you can actually get more of your solute in, Okay, and this is called supersaturated. All right. If you raise the temperature of your drink, so if you make a cup of tea, you'll be able to get more sugar into your cup of tea than you would into a cold glass of water. And that's because, and you may have watched the states of matter video, adding in heat is a type of energy, and that speeds the particles up, creates them to move a bit more, allows more room for the solute to mix in with the solvent. So here you can see just a cool little diagram, obviously really saturated down to not so saturated in terms of concentration. So let's put it to the test. Which of these solutions here, if these are the molecules under a super electron microscope, has the greatest and the least and no concentration of solute? So I want you to pause the video and maybe write a justification on why you think that, and let me know in class. So, how do we separate certain mixtures? Well, there are a number of techniques, and they're flashing up on the screen as I talk now. And all of these can be used together or by themselves to ensure that we can separate certain mixtures. We're going to go over a few of these now. And some of them you may have already done or heard about. Okay? And then this is where we get all the cool sort of apparatus out in chemistry, and we look like we are proper mad scientists. So it's pretty cool. So let's look at a magnet first. Well, a magnet uses the magnetic field of our planet and of certain metals to manipulate them, and it can actually attract magnetic substances such as some metals. So if you've got a mixture here we've got sugar and iron. Iron being magnetic means you can actually get rid of all the salt by just using a magnet, and it takes all the magnetic metal out of it. So it's quite a simple and effective technique. A little tip, always put a plastic bag around your magnet, otherwise it's really hard to get all of the iron off. Filtration is another method. So here you can see the steps of filtration. You've got a beaker, you've got a funnel, you've got some filter paper folded correctly. You also need another beaker with your nasty mixture in it. So maybe you're trying to separate some sand, water and salt to create pure drinking water. If that's the case, you just need to pour your mixture, once you've given it a good stir, into the filter paper. Okay? And then what will happen is it will gather all up here. Now this filter paper has tiny holes that you can't see, and they only let certain particles through. So these big sandy particles up here of the solid that is insoluble will be separated, but anything that is soluble will go through the holes in the filter paper. Now here you can see the little holes. I'm not sure, depending on your screen brightness, I might have to change the colour of that, but you can see the sand gets stuck, and anything that was in that mixture, maybe it was salt that's soluble, goes through here and out to the bottom of the beaker. And there we have it. Simple filtration. Separates a liquid from a solid. This is what you use if you've got an insoluble mixture mixed with a liquid. Okay, it's a really simple way to do it. You might have to do it a few times to get all of the solid out. There's another thing to think about. But what happens when we've got a soluble mixture, where we've got a solvent and a solute mixed together to make a solution? What do we do then to get and separate those two? Well, it's very simple. We use evaporation. Now, you've all seen this happen. If you've ever made a cup of tea for your mum or your dad, you would have seen steam coming off of the kettle. If we boil water to 100 degrees, it will evaporate. The particles get so excited they jump off. You can see the states of matter video to understand that process a bit more. But what happens is the salt or the solute or whatever it is, the raro, in the solution does not evaporate. The particles are too complex or too big to evaporate with the energy of the Bunsen. So what we can do is we can make our solution mixed up together, put it in an evaporation basin, and evaporate off all of the solvent, leaving the solute left, or in this case the salt or sugar or whatever it is we've dissolved into our solution. So the solvent will evaporate off, leaving behind our crystals, and it often forms crystals for our solutes, for us to use or discard, depending what it is. So there we have it. That is evaporation. You can pause this video here to see how you can do the filtration again with some words. I'm not going to go over this one too much. And mixing these two techniques together, the filtration and the evaporation, allows you to successfully separate not only an insoluble solid, a solvent, but also a solute. Oh, now what is all this? This is a pretty cool setup we've got here. This is called distillation. Now, if you evaporate your solute, if you use evaporation to separate your solute from your solvent, you're going to lose your solvent into the atmosphere. Now, that might not be a great thing. Maybe you're trying to purify water to drink and you need to capture it. Okay, so this is where this setup comes in. So it's very similar. You've got your what we call a distillation flask or a round bottom flask. You've got your Bunsen burner heating it, but it is a sealed system up until this point. So what that means is you've got your solution here, but you want to evaporate your solvent and you want it to travel down here. Now, if we remember back to states of matter, you know that a gas, once it has boiled, okay, can be cooled down to condense. Now, this is what this is, okay? It's called a condenser. The correct or the accurate name for the guy that invented this was the Leydig condensing tube, okay? And what it does is it pours water from the sink into a glass tube that has an opening in the middle. Now, what the water does is it cools whatever's in here. So on a cold morning, if you go up to a window and you breathe on it, you see that condensation. This is allowing that to happen to the hot, gaseous liquid that we want to condense to then get a pure sample at the end. So if you've got some nasty water and you've got this equipment, you can make pure water to drink here, because all the nasty solutes that have dissolved and made it contaminated will be left in our distilling flask. Okay, so this is how we use condensation to achieve separation, and this is called distillation. Here's just another setup that's pretty cool, so I'll let you have a look at that one. Again, condensing tube is pretty cool. You can get this out in class if you come and have a chat with me. Now, we've got another interesting way to separate things, and that's through chromatography. Now, chromatography is basically the separation of the size of particles. So, you know, in things like ink and colour, they're not actually one colour. You don't have, for example, a black pen. The black pen is actually comprised of lots of colours, and those colours are different sizes in particles. And using chromatography allows us to separate those into really cool patterns, like you can see on these tie-dye t-shirts. But you can also do the same for DNA. DNA has different sizes depending on the nucleotides, and you'll learn about those in biology. But what happens is the size of the particle will mean that it moves up a medium, usually paper for ink, okay, and usually a medium of sort of a jelly medium for gel electrophoresis, which is the scientific way of separating DNA. And what will happen is they will all separate, as you can see here, all right? And these are all different parts of your DNA sequence being separated. And they're used in, you know, looking at crime scenes and murder scenes because, you know, you might find a bloody cat hair at a crime scene, but using DNA, we can actually see that this person here, who's suspect 1 and suspect 2, and the cat has no DNA in common with this supposedly bloody cat hair from a murder. So we've got matches here and here, and that would be where we would look to see if this person was actually the murderer. So it's pretty cool. And this happens with colour. If you put a blob of colour at the bottom of a piece of chromatography paper, the colour will separate into distinct colours, which is pretty cool. So you might get a chance to do that in class as well. Here we've got the last of the the second to last separation technique, which is called decanting. If you've got anyone that knows how to drink red wine properly in the house, you'll know that this is a very important technique to get rid of anything in the bottom of you know, any liquid that has something in it. So what you do is you let the liquid settle, and you get a sediment at the bottom, okay, this insoluble sediment. And what you do is you very carefully pour your liquid into a new container. Now you can use a glass rod touching the rim because that allows all the water to flow using water tension down into the beaker and you won't spill any. And what you do is you keep pouring until you get near the end. Okay, it's not the most efficient technique, but it'll ensure that you don't get any of this sediment in there. Okay, so if you've got fresh water and sand in it, this is a good way to get that fresh water off the sand, okay, by using decanting. And finally, we've got centrifugal force. Now, the way I like to explain this one is really simple. How many of you, when you were younger, have grabbed two of your friends, sort of locked arms like this, and span around really, really fast until one of you lets go because you're being pulled away from each other? Okay, that's what centrifugal force is. Okay, you're being pulled away from each other. So, very simply, you spin something very rapidly, and the bigger, more denser materials go to the bottom or the outside of the flask. Okay, and it starts separating. And you can see this, and this is often used when separating blood. So this blood mixture is actually comprised of plasma, white blood cells and platelets, and your red blood cells. So here, by using centrifuge, you can get these components of blood. Now, each of these are very important for different things, and certain people need plasma, other people need more red blood cells, and maybe you need to analyze how many white blood cells you've got because maybe you've got an infection that you're fighting. So centrifugal force is another way to spin a mixture to separate it out into different sizes. Okay. Perfect. All right. So here's just a little graphic that you can pause and read yourself. How do you separate a sand-saltwater mixture? Very simple. We've already talked through it. But if you just needed something written down, here is a good example of it. Finally, we're talking about chemical and non-chemical physical changes. Obviously, when we're mixing and dissolving something, it is not a change in chemicals. So you can use distillation to separate your two substances from your solute and your solvent using this technique because the chemicals have not changed. If you react something together, you can't use these techniques because they have chemically changed, which means they are completely different molecules. So you have to do another reaction to get those back to the way they were. So I'm going to just let this play out, as you can see here, and this is a walkthrough of the solution again. So if you are, needing to see this in a step-by-step process, here it is. Okay, so just watch this nicely and speed the video up if you want for it to all come through. But basically, you start with your salt-crusted sand. Okay. To make sure you've separated it all, you might want to weigh it. You then need to fill it with water and make sure it's in something that can be heated. You don't want to crack anything. Okay. You want to suspend it in a solvent so the salt dissolves because the salt is a solute. All right. And remembering at this stage here, you might need to repeat, okay? Because you might not have filtered out everything, all right? And actually, at the end of it, you can weigh everything, and you should have the exact same weight of the three components, the water, the salt, and the sand, as you had at the start with your full mixture at the start, okay? Alrighty, and finally, if you're not sure which technique to use, here is a little choice map for you to get to the right solution. So, now you know all these words, miscible, insoluble, soluble, solutions, you should be able to follow this diagram perfectly to get your end result, which you are looking for. So, I hope you have learnt a lot of new words today. I hope it makes sense. And I hope now that if you have a challenge, maybe it's a survival situation where you need to separate water, that you can, because you know how to separate mixtures. Thank you very much for watching. Please come and see me if you have any questions. I'll catch you in class.